Alright guys, welcome back. In this video I'm gonna show an example of an application of inflection point. In the previous video we discussed the second derivative and the concavity changes, and that established the inflection point. So quickly we know that an inflection point on the graph x is where f changes is concavity, meaning the function can concave up before that point inflection and then concave down afterwards, or concave down to concave up. In economics, the term of inflection point is referred to point of diminishing returns. So this is defined as the dollar amount x, or the point where x is the dollar amount at which the rate of change of sales goes from increasing to decreasing by increasing on spending advertising. So what exactly this saying that you have a point where the function changes concavity, meaning the rate of change in sales, meaning the sales rate is go from increasing to decreasing. And in other words, for example, you have a product, for example, iPhone 11. The company spends a certain amount of dollars to advertise the new product. The first couple months, the first couple 10,000-15,000 or so, or even 100,000 of advertising, the sales rate is increasing quite a bit. But over time, 3-4 months later, or after 200,000 spent on advertising, the sales rate start decreasing. It's still increasing in a way, but the rate of increasing is slowing down. So that right there acts as a concave down situation. If we look at the graph here, suppose you have a graph that describes a new product, and then where x is the dollar amount, so this is be the dollar amount of advertising money, and then this would be the sales, the number of units sell for that particular product. And then you can have a graph that looks like this. Okay, so what's happening here is at this point here, right, you see how the graph kind of changes concavity from concave up to concave down after that point. So we can call this point there, that's the inflection point. Or we can say that's the point where, that's the dollar amount where, is the point of diminishing returns. Okay. Look at the slope of tangent line. You see how the slope of tangent line is increasing. Let me use different color here. The slope of tangent line is increasing before that point. It's increasing. The rate is increasing, and it start decreasing. The slope of tangent line start decreasing. You guys see that? And then furthermore, this saying that this is also the amount at which the rate of change has maximum value. Money spent beyond this amount make increase sales but low rates, meaning that at this point here, the rate of change is the max. The rate of increase in sales is the maximum at that point. Anywhere past that point is you still have a positive slope here, but that rate, that positive slope, is decreasing. Okay, so that's how we relate inflection point to diminishing returns, meaning the return at that point is slower than prior to that point. Another example I can think of is, in a classroom, for example, if we have a 2 hours classroom, and maybe after the first 45 minutes, your ability to be able to process material or process new material is much slower than the first hour or first 45 minutes. So it's kind of like the point where you have the two rates. You have the rates increase the most up to that point, and then it start decreasing here. Meaning we still process material, still process material, still, learning material, but the learning, the growth, the rate itself is much slower than the second half, right? So that's another way we can think of, in a sense of what is point of diminishing returns. So let's look at an example. Okay, so I want to do example from the homework. This is, I don't know what problem, I think this is problem 10 in 4.2. This saying that a company estimates that it will sell n of x units of a product after spending thousand dollars on advertising as given by the function negative 0.25x to the 4 plus 23x to the third minus 540x squared plus 85,000, where the restriction on the x values is 24 to 45, meaning the budget, this is the budget, this is the spending, this is the advertising money budget that we can have for this product here. We asked to find when is the rate of sales increasing and when is it decreasing, and then what is the point of diminishing returns and the maximum rate of change of sales. We probably won't spend time on graphing this here, so we're just gonna do the first part and not discuss on the graphing because that's not the focus of this class here. So if we ask to find when is the rate of change of sales increasing and when is it decreasing. So this here, the word in itself, this referred to the derivative. When is n prime, the rate of change of sales, mean n prime referring to the rate of change of sales, since n of x is the sale of this units of product. So it's asking for when is the first derivative increasing and when is this first derivative decreasing. So if it's asking, the rate of change of sales, that's referring to n prime of x. Okay, so we asked to find when is n prime of x increasing or decreasing, or n decreasing. Okay, so we asked to find an interval. Okay, and that interval is going to be between 24 to 45, and that's because that's the restriction of this graph. To do this, we use the concept of the second derivative. We know that if the second derivative is positive, that implies the first derivative function is increasing, and if the second derivative is negative, that implies the derivative function is decreasing. So maybe just kind of jot that down here. So we know, okay, if n double prime is greater than 0, that implies n prime is increasing in a given interval. Okay, and we also know that if n double prime is less than 0, then n prime is decreasing. Okay, so what we want to do is we want to establish a sign chart for the second derivative. To do that, we need to find the critical value for the second derivative. So we need to take the second derivative for this function n of x. Okay, so I'm going to go ahead and do that. So if n of x is given as negative 0.25 x to the fourth plus 23 x to the third minus 540 x squared plus 85,000. All right, so let's go through and find these derivative. We're looking at n prime of x, 4 times negative 0.25, that's going to be negative 1 x to the third plus 69 x squared minus 1080 x, and then the last term is going to be 0. Let's go ahead and do one more time to find the second derivative. So that's going to be negative 3x squared plus 138x minus 1080. So we got the second derivative. So what we want to do now is we want to set this equal to 0 to find the critical value. And the critical value for second derivative is a potential point of inflections, or the point of diminishing return. Okay, it's different from the first derivative critical value. All right, so let's do this. To set this equal to 0 and solve for x, we can factor out a 3, minus 3. So I believe 138 can divide into 3. 138 divided by 3, so that's 46. So it's going to be minus 46x plus 1080 also divided by 3. 360 equals 0. Negative 3 cancel out, so we get x squared minus 46x plus 360. The factor of this type of problem is maybe a little more challenging than the other one because the coefficient, the numbers are much larger than the other example we've done prior to this chapter. but I'm gonna go ahead and do this, and I'll show you guys here. To get 360 and add those two factors, you get 46. I'm thinking about 10 and 10 and 36. So we do 10 and 36 as a two factor. But then both of this has to be negative to make a positive 360 and make a negative 46. So that gives us two potential critical value, 10 and 36. The problem with this is that our restriction domain is only from 24 to 45, so we use this one. Okay. So now we can draw this second derivative sine chart. Okay. All right. So to do that, we draw a horizontal line. So this represents the x-axis. Okay. And then we said, all right, it's going to go from 24 to 45 is what we're looking at for the budget of advertising money, 24 to 45. And then the critical value is 36. So maybe 36 is somewhere here. I don't know. Let's say that's 36. All right. So there are two intervals. We'll look at 24 to 36 and then 36 to 45. We're going to test where the first derivative is increasing or decreasing in this case. So we divide that. Okay. And we're going to pick some x value to test. So maybe x equal to 25 there, or even 30. Let's do 30. 30, and maybe x is 40 there. And we're going to plug this into the second derivative to test the sign, and hence why the name is. All right, so once we pick the test value, we want to plug the test value into the second derivative function to see what the sign would be. So if I pick x equal 30 here, I want to plug that into the second derivative. We can plug into the factor form, and the problem with that is the factor form doesn't have the coefficient. The coefficient is negative. So what we want is we want to use this here. We want to use that factor form along with the negative 3 because that's going to change the sign itself. So let's see here. We want to write, let's do f double prime of x is minus 3, x minus 10, x minus 36. So we're going to use that second derivative factor form there. So let's plug in 30 for that. So let's go ahead and do, let me erase this here. So let's do minus 3 times 30 minus 10, and then 30 minus 36. This can be a negative times a positive times a negative. So this can be a positive. So that means the sign for the second derivative for this value here, second derivative is greater than 0. If second derivative is greater than 0, that implies that the first derivative, and I think we want to use n instead of f. Okay, so let's do n double prime, and then n, and that means n prime is increasing. Okay, all right, so the first derivative is increasing on this interval, and let's do the same thing for the second test point there. Let's plug 40 into the second derivative. 40 minus 10, 40 minus 36, so that's a negative, positive, and then positive. So that's going to be a negative result. That's less than 0. That means n double prime is less than 0. If n double prime less than 0, that means n prime is decreasing. Okay. All right. So now we have the answer for the first part. We say that the function. So it's asking for when is the rate change of sales increasing or decreasing. That means where is n prime increasing or decreasing. So we can say that the rate of change of sales is increasing, on the interval from 24 to 36, 24,000 to 36,000 spent on advertising, and then decreasing after that on 36 to 45. Okay. Another thing too is that because we have n double prime goes from positive to negative, in this case here, guys, go from positive to negative around 36. So that means the function also changes concavity. So this is going to be part B, because n double prime goes from positive to negative at x equal to 36. N of x changes concavity. So that means x equal 30 is a point of inflection. In other word, x equal 30. Actually, in other word, x 36 comma n of 36, okay, is a point of diminishing returns. Okay, so that's where the point of diminishing return is. Okay, so that's the answer for the second part. Now, the third part is asking for where find the maximum rate of change cells. So this is where the rate of change is the maximum, meaning the first derivative obtained the maximum rate of change at that point. So that's gonna be not n of 36, but so we say the maximum rate of change of cells occurs at x equals 36. And to do that, to find that, we're going to do n prime of 36 because the first derivative referring to the rate of change function. So to find the maximum rate of change function, we plug 36 into the first derivative. And so that's going to be x cubed. So that's going to be negative 36 to the third plus 69 36 squared plus minus 1080x minus 1080x minus 1080x 1080 times x is 36, and whatever that turns out to be, let's see what that would be here. So negative 36 cubed, all right, plus 69 times 36 times 36, and then minus 1080 times 36, and so we have 3888. So this means the maximum rate of change is 3,888 units of that new product per $1,000 spent on advertising. Okay. All right, guys. So I hope that helps clarify the application of point of inflection. Feel free to ask me these questions about this video when we get on Zoom.